Now see this question. Let capital G comma star be a cyclic group of order n. So what do I mean by that? The number of elements present in this group are n with generator A, which means they are also saying that there is a generator in it which is A. So one of the generator they are giving us, but then is it the only generator? We don't know that, but the theorem is saying that the number of generators in G is equal to phi of n, where phi of n is Euler's function of n. So what is Euler's function of n? The number of, see, phi of n is nothing but the number of numbers less than n, the number of positive integers less than n, which are relatively prime to n, is called as phi of n. For example, I think we have already discussed it, right? So what is phi of 3? The number of integers which are less than 3, which are relatively prime to 3, the positive integers are 1 and 2. Therefore phi of 3 is 2. What about phi of 7? The number of integers less than 7 which are relatively prime to 7. So since 7 is a prime number, all the positive integers less than 7 will be relatively prime to that, which means it will be 6. 1, 2, 3, 4, 5, 6. What about phi of 6? The number of positive integers less than 6 which are relatively prime to 6. So it is going to be, I think, 1, 2 is not relatively prime, 3 is not relatively prime, 4 is not relatively prime, 5. So 1 and 5, which means 2, right? So that is the meaning of it. So in case if a group is having 3 elements, then the number of generators it will have is 2. If a group is having 7 elements, then the number of generators it will have is 6. See, this is about cyclic group. It is not valid for all the groups, only for cyclic groups where we know that there will be at least one generator. We are trying to find out how many generators can be present. So observe this. If the group is containing 3 elements, then it should at least have 2 generators. 7 elements, it will have 6 generators. Exactly. 6 elements, it will have 2 generators. That is the meaning of it. And A power m is also a generator of G if GCD of m comma n is 1. So what they mean by this is, see, now you have found out that 1 and 2, 1 comma 2 are present in S3. S3 means the number of elements with the number of positive numbers which are less than 3, which are relatively prime to 3. Got it? So since 1 comma 2 are present in S3, if A is a generator, then A power 1 and A power 2 both are going to be generators. That is what the second statement is, which means A power 1 and A square, these two are going to be the generators, right? And in this case, since 7 is having a 1, 2, 3, 4, 5, 6, all these numbers in S6. If A is a generator, then A power 1, A power 2, A power 3, so on, A power 6 will all be generators, right? In this case, yes, if A is a generator, then since S6 is having 1 and 5, which means the number of numbers which are less than 6, which are relatively prime to 6, are 1 and 5. In this case, you are going to have A power 1 and A power 5. These two are also going to be generators in case if A is a generator. That is the meaning of the second statement. Got it? So why is this useful? This is especially useful if you are trying to find out the number of generators that can be present in a cyclic group with n elements. Got it? So how many generators will be there? Phi of n. And what are all the generators? If you can find out one generator, you can just simply raise it to the power of some number and you can find all the other generators. Let's see this example. Let's check this one. Let capital G comma star be a cyclic group of order 8 with a generator small a. Then the number of generators in G is, now we know that the number of generators in a set is going to be simply phi of n. So in this case, phi of 8. So what is phi of 8? You have to find out the number of elements in S8, which is nothing but the number of positive integers less than 8 which are relatively prime to 8. So 1 is relatively prime to 8, 2 is not relatively prime to 8. I think you remember what is relatively prime, right? So what is relatively prime? GCD of 2 comma 8, if you find out, 2 2 divides both 2 and 8, that is the greatest common divisor, isn't it? Therefore, if GCD is not equal to 1, then they are not relatively prime. If GCD is equal to 1, they are relatively prime. Since GCD is not equal to 1, they are not relatively prime. So 2 is not relatively prime, but 3 is relatively prime because the greatest common divisor of 3 and 8 is 1. 4 is not relatively prime because the greatest common divisor of 4 and 8 is 4. 5 is relatively prime, and 6 is not relatively prime because greatest common divisor is 2. 7 is relatively prime. Therefore, these are all the numbers which are less than 8, right, and which are relatively prime to 8. S8 contains all this. Therefore, what about phi of 8? Phi of 8 is nothing but the cardinality of S8, which means 4. So by this theorem, if a group is having 8 elements, cyclic group, then it should definitely have 4 generators, right? So how many generators will it have? It is going to have 4 generators. That is the first answer. Which of the following is not a generator? So if A is a generator, then what can you say about it? A power 1 is a generator, A power 3 is a generator, A power 5 is a generator, and A power 7 is a generator. All these are going to be generators, right? 1, 3, 5, 7, all these are going to be generators. But then here if you look at it, yeah, so you are not going to have, where is it? Yeah, so if you look at it, here you have A square, A cube, A power 5, A power 7. A power 7 is a generator, A power 5 is a generator, A power 3 is a generator, but A square is not a generator. Got it? So you can just extend it to any equation. For example, if they say that the cyclic group is having order 9 instead of 8, then how can you solve it? The same way you can solve it. So what is it? You have to find out phi of 9, right? Yeah, but then there is a small difference here. So yeah, let's find it out. I'll tell you a shortcut also. Here let's find out phi of 9. What are all the numbers which are less than 9, which are relatively prime to 9? You are supposed to get 6. Okay, let's find out. Yes, 9. The set of all numbers which are less than, positive integers less than 9, relatively prime to 9. It is 1, 2, 4, 5, not 6, 7, 8, right? So it is 6. Got it? Now if A, so therefore the first answer is the number of generators in this group is going to be 6, right? And what about the all the generators? If A is a generator, then definitely A power 1 is a generator, A power 2 is a generator, A power 4 is a generator, A power 5 is a generator, A power 7 as well as A power 8. All these are the generators, right? But the problem with this method is as this number n increases, it will be difficult for us to find out the this number using that method by counting. See, how am I finding out phi of n here? I was actually counting this, right? But then there is a product rule. So product rule says that if n can be written as product of two prime numbers p and q, then phi of n can be written as phi of p into phi of q, in case if these two are distinct prime numbers. Okay, remember this. If n can be written as product of two distinct prime numbers p and q, then phi of n is equal to phi of p and phi of q. Then what is the advantage of this? Advantage of this one is, if p is a prime number, then phi of p is always going to be p minus 1. So why is this so? Because if p is a prime number, then all the numbers less than p, from 1 to p minus 1, all these numbers will be relatively prime to p. Got it? All the numbers which are less than p will be relatively prime to p. In that case, phi of p is going to be p minus 1, which means phi of 7 is 7 minus 1, 6. 1 to 6, all these numbers are relatively prime to 7. And similarly, phi of 11 is 10. That is what the meaning is. So why is it useful is, now let's say I want to find out phi of 77. Now instead of directly finding all the numbers from 1 to all this, you can write this phi of 7 as phi of 7 into 11. Then it can be written as phi of 7 into phi of 11. Then it is nothing but 7 minus 1, which is 6, into 11 minus 1, which is 10, which means 60. 60 numbers are less than 77, which are relatively prime to 77. Therefore, if a group is having 77 elements, then the number of generators is going to be 60. But if you want to count using this method, it is going to be very difficult. If you want to see one more example, you can see this. What about phi of 35? Phi of 35 can be written as phi of 7 into 5, right? Then what is phi of 7 into 5? It is phi of 7 into phi of 5. Then what is it? Phi of 7 is nothing but 6, and phi of 5 is nothing but 4, which is 24. So for 35, if group size is 35, then the number of generators is going to be 24. Got it? And there is a small exception here. When you apply this factorization method, sometimes there will be a problem that some of the, this method is applicable, or this formula is applicable only when they are distinct prime numbers. For example, if you have 25, right, if you try to write phi of 25, it is going to be phi of 5 square, isn't it? Phi of 5 square. So whenever you have repetitions, then you have to use a different rule. That is one rule where you don't have repetitions. Whenever you have repetitions, the rule is phi of p power, let's say n, is equal to p power n minus p power n minus 1. So in this case, it is nothing but 5 power 2 minus 5 power 1. So which is nothing but 20. If you directly use that rule, if you write phi of 5 into 5, and then it is phi of 5 is nothing but 4, you will get 16, isn't it? But then apply this formula. In case of repetitions, it is going to be like this, right? So phi of 25 is like this. What about phi of 125? Phi of 125. Phi of 125 is nothing but phi of 5 cube, right? Then what about this? P power n minus p power n minus 1, which is nothing but 125 minus 25, which means 100. Okay. So if you go by the other that formula, you will not get correct answer. So just be careful when you are trying to find out the Euler's numbers. In case if there are repetitions, you have to apply this formula, p power n minus p power n minus 1. In case there are no repetitions, you can directly apply p minus 1 into q minus 1. What if there is a combination? Combination means if there is a repetition as well as other numbers, right? So just see how to write it. Let me say the number is 84. If you see 84 can be written as 2 square. 2 is a prime number, and one more thing, we are going to use only prime numbers, right? So only for the prime factorization we are going to apply this. So 2 square into, I think, 3 into 7, okay, 21 into 4, yeah, so it is 21 into 4. So in this case you have got 2 distinct numbers and 1 repetition, right? So how are you going to do this? It is going to be phi of 84 is equal to phi of 2 square into 3 into 7. Now you can split it. Phi of 2 square into phi of 3 into phi of 7. So you can as usual write it as 2 minus 1, and you can as usual write it as 7 minus 1, which means this one will be 2 and this one will be 6. But then this one is different. This one is going to be p power n minus p power n minus 1, which means 2 power 2 minus 2 power 1. So which is nothing but 4 minus 2. 4 minus 2 is 2. So it is going to be 2 into 6, which means 24. Got it? So just be careful. Any number n, you can apply this product rule when n can be written as product of prime numbers. In case if all the prime numbers are distinct, you can write phi of n as p minus 1 into q minus 1. In case if there is repetition, right, like p power n or p power k, right? Then phi of n is going to be p power k minus p power k minus 1. In case if there is a combination, you split them and then apply the formulas appropriately. Got it? Okay, so anyway, in exam I don't think that they will give you any number which is not easily prime factorized. So this is called as prime factorization. When you are writing a number as a product of two prime numbers, it is called as prime factorization. Okay, in exam they will most probably be giving you small numbers which will be you will easily be able to detect to write it in a product of prime numbers. For example, 35 7 into 5 or 25 5 into 5, like that. Okay, fine. So you can follow this method. This theorem is very important.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries, for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.